Thank you everyone for joining us. I'm just going to give it another minute as we allow our attendees to filter in from the waiting room before we get started, if you bear with us. Thank you. Okay, hello and welcome everyone. Thank you for joining us for today's webinar. My name is Laura Egan O'Brien and I'm the Marketing Manager for the College of Engineering and Architecture here in UCD. I'm going to be your host for today's session, so whether you're joining us from near or far, we're thrilled to have you with us. This webinar today is all about study opportunities and the kind of future careers you can get from courses within our School of Chemical and Bioprocess. I'll be joined by two of our academics and one of our current students to give their experience so far, and we hope you find today's content both engaging and informative. So before we get started, just to let you know that if you do have any questions today, please type them in using the Q&A button at the bottom of your screen, and we'll get through as many of your questions as we can in the time that allows. Also keep an eye on the chat as my colleague Kate O'Neill is joining us as well, and she'll pop any useful links that are mentioned throughout the webinar today in that chat box there, so do keep an eye on it and grab those links as she posts them. And then lastly, just to let you know that the session is being recorded today. So if you miss anything or have to leave early or know of anyone who couldn't be here today but would find the content interesting or useful, that link will be shared with everyone for the recording if you've registered for the event today, and also posted on our college YouTube channel early next week. So that's really all from me. We're going to get started with the rest of the session as planned. So first up I have is Dr. George Pesh, who's our program coordinator for our chemical engineering masters.
Right, I'm just gonna go share my screen here. Right, this is working. Right, thanks everyone for joining. I hope you can see my screen, otherwise just give me a voice note if not. My name is Georg Pesch. I'm in UCD since 2022. I'm an assistant professor and lecturer here within the school, and I also do a bit of research, and my research is in particle separation. My background is in chemical engineering, so I moved to UCD from Germany almost 3 years ago now, and did my undergrad and graduate in chemical engineering and have a PhD in chemical engineering as well. And today I want to introduce firstly our school, the UCD School of Chemical and Bioprocess Engineering. And afterwards, I would like to introduce the Master of Engineering Science in Chemical Engineering, which is a one-year master program. So the Chemical Engineering School is rather old. We'll have our 70th anniversary in 2026. It was first established in what is called Marion Street in the center of Dublin. It's a fantastic old-fashioned building. It's now where the Irish Prime Minister, he's called the Irish Taoiseach, has his office. At some point, this is the old building which you can still see in the city center. A number of years ago, a number of decades ago, I have to say, we moved to a very beautiful campus in the south of Dublin, which is the so-called Belfield campus, and we have this engineering building which was built in the 90s, and it's surrounded by this beautiful lake with swans and other animals, and it's really quite scenic. So in our school, which sits within this building within other engineering schools, we have 19 faculty. 4 of those faculty have a joint appointment with NIBRD, and Colin will speak more towards what NIBRD is. We have 15 plus research fellows, 40 PhD students, 7 support staff. We have 170 undergraduates, more or less, roundabout, continuously. We have more than 1,500 graduates up to now in chemical and bioprocess engineering. And at the moment, we have roughly 45 Master of Engineering Science. These are dedicated master students, both full-time and part-time. I think it's very important to note here that the School of Chemical and Bioprocess Engineering is Ireland's oldest, largest, and highest ranked chemical engineering school. And it really has a long and prestigious history within Ireland to produce skilled graduates in chemical engineering. So this all started in 1956. You can see class size in 1956 was rather small. We have these three cheerful looking lads, and it developed quite a bit from then. This is a picture from 2017, so this is, 60 years later. And you can see, luckily, it's not all men. It's a good mix of men and women, or almost half of our graduates do not identify as men. And you can see we produce roughly these numbers every year in terms of graduates from our undergraduate program. So these would be students that would exit with a BE or with an ME every year. As I said before, we have over 1,500 chemical and bioprocess engineering graduates since 1956. And we can have a look at where these people are going. 70% of these graduates stay within Ireland, 10% move to the UK, another 10% moves to the US. Surprisingly, only 5% goes to the rest of Europe, and then 5% goes to the rest of the world. And these graduates traditionally work in a number of sectors. One, and that's the biggest sector within Ireland, is for our graduates, the pharma and biopharma sector, which is just because Ireland produces many, many, many pharmaceuticals for companies around the world, and has many of the big biopharma and pharma companies have their production sites in Ireland. So they are really a big, big employer for our graduates. And then 25% of our graduates work in the chemical sector. Another 20% work in the engineering sector, which basically means they work for engineering firms that are traditionally hired for smaller engineering tasks. So they would move from job to job and do different kind of engineering works for different contract companies, basically. 15% would be in the business sector, 5% would be in the public sector. So that would be people like me who are lecturers, or people like Colin. There are different public sector works as well, which are outside of the university field. And then 5% go into the food and drink industry. And if you know Ireland a little bit, then you know that we produce both Guinness as well as Jameson whiskey, which would be traditional employers for people that have a chemical engineering degree. And then food, you could work, for example, in a company that makes cheese or dairy products, or other kinds of sectors. So if you look back at this class from 2017, there's just a number of companies, and you might not know these companies. That's fine if you're not from Ireland. We have traditional pharma and biopharma companies that would be Alexion, APC, Amgen, BMS, Lilly, MSD, and Pfizer. These are, really big players in the field of pharma and biopharma. Lots of people go into consulting companies, and these are just a number of consulting companies that are in and around Dublin and Ireland, which basically mean that you would be working as an engineer for these companies, and these companies would then do jobs for other companies, essentially. So they would be hired because, say, a company doesn't have a specific set of expertise, so they would hire these consulting companies, and then you as an engineer would come in and basically solve a specific set of problems for them based on your expertise that you have. There's a couple of other companies. For example, here's a cement company listed, or Bodnar Mona, which I think does something with peat. I'm not entirely sure. And some other people would go and do postgraduate studies, which would mean do a master's, for example, in chemical engineering, or they might do something like project management. Right. So this is the introduction towards our school. I now want to just give a brief overview of the Master of Engineering Science in Chemical Engineering. This is a full-time program. I am the program director of this program, and it is essentially a 90 credit program, which means it's 12 months in length. So it has in total 12 lecture modules, which are worth 60 credits, and then it has a 30 credits research project. So you would start in the autumn trimester, you would have 30 credits in the autumn, then you would have 30 credit lectures in the spring, and then in the summer you would do a 3-month research project. All of our lectures are delivered in person. And the suitability of this program is basically for students with a BE or a BTech or something comparable in a field like chemical engineering, chemical technology, or something comparable. So the suitability of this program is for people that have an undergraduate in chemical engineering, and they're looking for an opportunity of further study to basically get further advanced chemical engineering knowledge in chemical engineering, and who might be interested to relocate to another country like Ireland. So we have a mix of scientific and industrial content, and all of our content is really aimed at advanced chemical engineering knowledge, which means that students that come in are required to have a bachelor or in something which is chemical engineering or chemical engineering adjacent. So the program structure is, as I said before, is one module there's 30 credits in the autumn, 30 credits in the spring, and we have subjects such as reaction engineering, advanced separation processes, advanced heat and mass transfer. We have two design modules, one in the autumn, which is advanced process design, and then we have a second design module, which is chemical and bioprocess engineering design in the spring. We have environmental engineering, process sustainability and renewable energies. We have a process control module and a characterization module. So these are the taught modules that we have in our program. It's a fixed curriculum. There is currently no option modules, although this might change a bit in the future, but at the moment there are no options and it's a fixed curriculum. And then finally, which is I think one of the most important and most inspiring modules is in the trimester 3 in the summer, we have the chemical engineering project where you actually go into the lab. You're supervised by an academic supervisor at UCD from within our school, and you will do an experimental or numerical project or a combination of an experimental or numerical project. And ideally, you would go in the lab and actually do experiments for a number of months and come back and analyze your experiments and do a write-up of the results that you've received and basically then create what is called a mini thesis on the work that you've done. And if that goes very well, there might actually be the opportunity to publish a little paper on that. And the idea here is really that you would go and create scientific knowledge that wasn't there before. And that's where you can go deeply into specific topics that you might find interesting that would be supervised by an academic from our school. Right, I'm already at the end of my slideshow. This is my little introduction to the School of Chemical and Bioprocess Engineering and to this program. And with this, I'll just going to go stop sharing my screen and we'll give the word to Colin to introduce the other programs.
Okay,
Great, thank you
I'll
so much. Yes, Colin, it's your turn. And Colin is our director or program director for our Masters in Biopharmaceutical Engineering.
okay. So everybody should be able to see my screen. Um, okay, so just a little bit about me. So as Laura said, I'm the program director for the full-time MN JSE in biopharmaceutical manufacturing. I'm a faculty position in the School of Chemical and Bioprocess Engineering in UCD, but I'm also a principal investigator at another institute called the National Institute for Bioprocessing Research and Training, or NIBRT. I have over 15 years in biopharmaceutical manufacturing research, and my research group focuses on the application of data analytics and also looking at the cellular systems that are used in biopharmaceutical manufacturing. So if anybody's not familiar, this course specifically focuses on biopharmaceutical manufacturing. And to give you an idea of the complexity of what we're trying to do, so many people will take aspirin or paracetamol. We call those small molecule drugs. So on the left-hand side, you can see aspirin. So first thing to notice is that it's a very small molecule of 21 atoms. And on the right-hand side, we have a bispecific antibody, so a next generation antibody. It's a much bigger molecule. It's much more structurally complex. And what you can't see on this diagram is that it has to have a perfect structure and it also has to have perfect sugar patterns. And if a company doesn't get that right, it's essentially a life-altering situation for a patient. So we need to be able to make the molecule in economically viable quantities. It has to be the right structure. It has to be the right sugar patterns. So what's that's given rise to is an incredibly complicated manufacturing process. And aspirin is very much like a bicycle, but when we get to a recombinant protein or a gene therapy or cell therapy, it's very much like a Formula One car in terms of its complexity. So extremely complex. It's also extremely highly regulated. So we have organizations like the FDA in the US or the EMA in Europe who regulate the manufacture of these medicines. It's extremely expensive and it's very, very challenging. So what our course is all about is training people to work in biopharmaceutical manufacturing operations. And Ireland is a global leader in making these medicines. So the course is accruing lots of different experience from our faculty, but also selected industry professionals who deliver content across the course. So Ireland as a destination, we have top 10 biopharmaceutical companies. I think we've about 90 companies operating in Ireland at the moment, 22 manufacturing facilities, over 12 million in investment in new sites, and all the time we're seeing new companies come to invest in Ireland. So it's a big part of our sector. And this course is designed to give students a start in working within the industry. So the course itself, we deliver both on a part-time and full-time basis. So it's nearly running for 20 years at this stage, the full-time program. So it was established to meet the demand in Ireland, and that demand is continuing. A key thing about our course, it's delivered in cooperation with NIBRT. And we also then have industry professionals who deliver selected modules. So students are able to get up-to-date information. They're also able to get an industry perspective on the skills that are needed. And to date, we've over 400 graduates who have been employed nationally and internationally. At the moment, we have students from all over the world: China, Germany, India, Ireland, Mexico, and Romania. And the intake for the course, it's designed to be suitable for graduates from science, but also from engineering. We have academic staff that you can see on the screen who are experienced across all facets of biopharmaceutical manufacturing. So from the creation of a drug substance in terms of the cell culture through to downstream purification of the drug substance when it comes out of a bioreactor through to fill finish and then formulation. Kind of a key asset of the course is NIBRT. So we have a partnership with NIBRT to deliver both modules in terms of formal teaching, but also then for students to go to the NIBRT facility. So NIBRT is a unique facility. It was built with IDA investment. It's a simulated GMP facility. So it's designed to be exactly the same as a biopharmaceutical manufacturing plant, just a little bit smaller scale. So it's a 60 million euro building. It replicates exactly what a biopharmaceutical plant is like. When students come to train at NIBRT, they wear the full gowns, they behave in exactly the same way as they would at a manufacturing site. And it shows students what the industry is like. It shows them day-to-day operations. You're physically in the environment, and you're at that time you're receiving training from the NIBRT staff in terms of how you operate in the facility, the different steps. You get this physical appreciation of what a plant is like. And that's in terms of the upstream part, which is large scale cell culture, purification, and fill finish. So it's an amazing facility, and we're very lucky to have NIBRT being a partner on this course. So back to the kind of overall structure. The structure of the program is designed to show students each part of the manufacturing workflow. We focus on recombinant therapeutic proteins, so monoclonal antibodies, different types of protein formats, but increasingly we're looking at next generation modalities. So gene therapies and then also cell therapies. The overall program is 90 credits, but the full-time program runs over 1 year. It's split into 3 trimesters, autumn, spring, and summer. The program is 90 credits. There are a total of 12 lecture modules comprising of 60 credits. There are 10 core modules that you must do. And then you also have 2 optional modules within the spring trimester. And then at the end, we have a capstone project or a summer project, and that's worth 30 credits. If you're interested in finding out the information on individual modules in more depth than I'm presenting here, please go onto the UCD website, search for the MNGSC in biopharmaceutical engineering, both for full-time and also the part-time options. And you can find out much more detail about what you learn in each module and things like the type of assessment. Okay, so to talk a little bit more depth about the 3 trimesters. So autumn is the first trimester. We begin in September. And really what that's aimed at is giving students that first overview into the industry, letting students gain those skills that they need for their careers and also for the second half of the course. So we do modules like Principles of Biopharmaceutical Engineering, so really foundational, animal cell culture technology, which is critically important, how to design and operate a facility, regulation, and then also analytical science. So how do we measure the performance of a process? How do we measure the quality of the product that we make? But really a key thing in the autumn trimester is students are early on within the trimester in the NIBRT facility. So this is a foundational module. Again, where students can come into the NIBRT facility, they can gown, they can go in, physically see the types of equipment to be in a facility. And that really provides an excellent grounding for students, because all of the modules that follow that, they can constantly refer to things that they've seen, places that they've been within the NIBRT facility. So really it is a foundational part of the course, getting to the NIBRT facility early, because that helps students understand what our plant is like and why we're teaching the types of subjects that we teach for the remainder of the course. Then we're into the spring trimester, trying to focus on downstream, how to design a process, things like scale up, tech transfer, gene therapy, GMP manufacturing. So we do have core modules, but then some options. The bioprocess scale up and tech transfer, that's delivered by an industry professional who comes from MSD in Ireland, and the course is totally delivered by that industry professional. So you're able to hear from somebody who spends their day-to-day working life within one of these companies. So really up to date information on scale up and tech transfer, a real world perspective. Students also do data analytics for biopharmaceutical manufacturing in the spring trimester. So how do we analyze data from lots of different places within the manufacturing plant? The other module that students do is research methodologies. So this module is designed to help students formulate their summer projects. So how to understand how you can design a project, how to understand how to do a literature review, so you can understand the current state of the art. So that prepares students then for the summer project. The summer project itself is 3 months in duration. Students can do an industry study, or they participate within the research group of faculty. And really the overall aim of this project is to prepare students for the next steps in their careers. So some students want to immediately go into industry. So working with the student to identify where open roles are, taking students' interests into consideration. So we're able to formulate a project that builds that student's CV to put them in the optimum position to compete for open roles within companies. And then on the research side, preparing students who might want to go into a manufacturing science technology role in the laboratory of a company, or indeed those students who want to go on and do postgraduate study. So at this stage, we're really focused on the next step for the student. What happens after the master's? And I should also say that over the course of the year, we run we run career development workshops. So students will hear from an academic. Students are taught that this is what an academic career looks like. Here are the things that happened. What are a PhD? What's a PhD? How do you select a PhD? We also then invite a recruitment company in the spring trimester to come in and talk to students about aspects such as statistical trends and where open roles are, how to formulate your CV, what's a good cover letter, how to network, how to use your LinkedIn profile. So we have a lot happening over the course of the year to prepare students for their graduation. and to put them in the best position for the next stages of their career. So I really gave a lot of information on the full-time program, but we do also have a part-time program. And the program director is Niall Barron. That runs over a two-year course. There's a lot of intersections between the full-time and the part-time course, but really part-time is designed for students who are in industry roles. So it's a really flexible delivery model. And again, it spans that diverse range of modalities from recombinant proteins to cell and gene therapies. To give you an idea, so for the first year, the activities happen in autumn and spring trimesters. There are 3 modules in each of those trimesters, and they're core modules, so they have to be completed as part of the course. In the second year, then it happens over autumn and spring for taught modules, and there are options within those. And then, of course, for the summer project, and that's a 30-credit module, and students then typically select a topic that aligns with their current role if they're in industry. Okay, so where do graduates go next? So from looking at previous years, our graduates end up working across biopharmaceutical manufacturing of biologics and cells and gene therapy. They work in what we call upstream, so expanding cells in large vessels, downstream operations, purification, equipment validation and commissioning, and also then to QC, quality control or quality assurance roles, where they look at the final product. So the course is really good at preparing graduates for lots of different places along the chain of creating these products and different operations, and also in the quality aspects. Our graduates have gone to a variety of different companies. I won't list them out, but places like MSD or Alexion or Pfizer. And we really do focus on working with the students to prepare them with specialist career advice, and so they can go on and secure employment at these companies. And over the years, just some examples, you can read them for yourselves, that people have gone to work for a wide variety of different companies and in different roles. But also they're prepared if students want to go on and do a PhD, they're prepared, and they're prepared for that through their summer projects. We also have an annual award that we give to the best student. So you can see Cheryl Lim won the award in 22. You see some examples from Thomas and Kate about their careers in Regeneron and Amgen. So really our students do have a lot of success when they finish the course. Just to finally mention that we also have a shorter course specifically focused on new modalities. So manufacture of cell and gene therapies, as well as next-gen vaccines. So this is a professional certificate. And, if you go onto the UCD website, you'll be able to find out more in-depth information about that. Okay, so that's the end of my presentation. So hopefully I've given you a good appreciation of the talk courses that we have, and specifically focused on biopharmaceutical manufacturing. And of course, if anybody has any questions, we're always happy to take questions from students, either now or if you'd like to follow up via email on the completion of the webinar. So thanks very much.
Great. Thank you so much, Colin. We're going to move on now to the student experience. So we have Cassandra, who's a current student in our biopharmaceutical full-time program. So she's going to give it more about how it's been on that particular course.
Hi, everyone. I hope I'm audible to everyone. So I'll be giving you all a little bit background about myself and why I chose UCD and why the particular flows MENJC Biopharmaceutical Engineering, and some of my experience for all of you guys to, for starter pack. So I'm Cassandra, and I'm currently doing my master's in biopharmaceutical engineering, and I came in last uptake, and then it has been a very good ride until now. So to give a little bit background, I come from India, and I did my undergrad in biotechnology, which was engineering BTech biotechnology. So I was wondering actually if I were to go to abroad or just do my master's in India itself. But as if international students will know, and from my familial background and my financial position, I had to try something which will give me a secure path for my future, but that was not there, and I wasn't sure of my future at all. So this was actually a last minute decision, the entire abroad thing. But still, I found this course. The major thing that actually attracted me to UCD was this course, biopharmaceutical engineering, because basically it's like a hybrid course. You have biotechnology, pharmacy, and all of that in an engineering point of view. So that was kind of like, when I saw that and I read throughout the modules, which I would ask all of you guys to do, whichever course you're interested in, just go through the modules and see how it fits with your future career prospects, so that it will help and like pave a way for you to go in. And that's why I actually chose, because the modules and everything is will equip you to your career, like your future career, and how you'll go about your day with as a process engineer, or as a scientist, or even if you were to go to like do a PhD. So all the module credits had this thing. So, and that's why I choose the course. And then this course was actually only available at UCD, and the modules especially. So I chose UCD for that. And that would be basically it for why I chose UCD. And some interesting aspects of the course, as Colin said before, is the collaboration with the NIBERT, and the most of the modules are given like on lectures. And as I'm doing my course as a full-time student, so I'll be attending classes, and then you will have a very flexible timetable though, because in this semester I only have like 2 to 3 days of classes, and then mostly you wouldn't be taking much of examinations. It'll be mostly assignments, team projects, and group works, presentations, disseminations, etc. So that was actually a very good thing for me, because we usually stress a lot with examinations and everything, but these assignments are made in a way that you actually show your professors that you have learned something, and it's not something that you could just type in on AI modes and just make the assignments good, but you kind of let them know what you have learned personally and how you would introduce something new, to do something novel. So that's how the entire course is built on. And you'll be mostly working on the manufacturing part and the production part. And the group that I'm currently working with, my teammates, also are made in a way that you create your own biopharmaceutical facility. So you'll have almost all of the things that's needed to actually build an entire biopharmaceutical production. So you'll have enough knowledge for that. And you'll also be touching various softwares. Like in the first semester, I was learning R program, which I had absolutely no idea what it was about. But I've had the small projects coming up, and then you learn step by step, and you actually learn a lot with the programming. You also learn in the statistical side of the biopharmaceutical engineering. So you're almost prepared for everything that's going to come at you in the biopharma. And the teaching would be also, the lectures are usually interactive, and it's almost all of the classes would be interactive, and you could just ask any questions to your professor. You could just mail them about any doubts that you have, and they're all very coming at you. And then in this recent semester, we also have this GMP class where a professor has brought in professionals, actual professionals like CEOs and process engineers. They just come every Friday and give you lectures. So you'll have the perspective of a working professional. So you know what you're doing, and you're not, in a place where you don't know what to do hereafter. So you're kind of guided all the way through. And then coming to my career goals, I've actually wanted to go into the downstream at first, but actually after most of the career fairs that I attended, there's usually something that's always there at UCD. You'll be having career fairs almost every week, but it depends on which one you want to go. And we just attended a NIBERT career fair last week, actually. And then I came to know that there were lots and lots of opportunities. And for me, especially, I'm a fresh graduate. I'm a recent graduate, so I don't actually have any working experience. So that would be like a fear for so many students, so many upcoming international students, especially because we might not have any working experience. And in my class, especially, there are so many people who have experience. There are chemical engineers, there are bioprocessing engineers who have almost like 5 to 6 years of experience. So at first, it would be very overwhelming. It was pretty overwhelming for me. But after actually coming here, I've actually got a part-time job at UCD itself as a research assistant under the head of department, Jessica. So I'm actually working on that job for almost 2.5 months now. So they don't actually need your work experience. They just need to see how curious you are about your own subject and how well you've understood the concepts and you're willing to learn more. So I think that would be some, I wish that someone would have told me that you didn't have to like get scared, all that. So I would tell you guys, if you don't have any work experience, and even if you do, you don't have to actually fret. You could just come here and learn whatever that's given to you and then apply it there, and that would be pretty helpful. So I've also had helps from the CV 360, from the career portal at UCD. So I have customized almost most of my CV. I didn't know actually how a CV looks. Back there in India, we usually have our pictures there, and then you just point out what were your experiences. But here are some tutorials, and there are some many videos out there in the portal to how to actually build your CV so that it would be recognized by the ATS system, and it would be recognized by the HR, and how you'll be actually recruited. So that actually helped me a lot. And I guess I have been applying for so many industries now, and you'll be getting rejected. Sometimes you'll get accepted, but it's not a big deal, and it's not the end of the world. And I'm still trying, and I'm very the part-time, the research assistant job is such a rewarding experience for me. So that would count basically as my Irish experience. So I'm looking forward to it, and I think that's mostly it. And if it comes to extracurriculars, I'm also indulged in most of the societies. There are drawing societies. I'm a part of a Christian society, Living Stones, and then there's a lot of societies out there and sports and everything. So if you guys could actually manage your time efficiently, you could excel both academically and personally, and you could actually learn a lot of things. And that would be it. And if you guys have any questions, do let me know. I'd be very happy to clear them up. Thank you.
Great. Thank you so much, Cassandra. Really great overview of your experience so far. And hopefully those listening in has found that useful. We are going to move on now to the Q&A part of our session today. So if you do have questions, as we mentioned at the start, please type them in using the Q&A button at the bottom of your screen. We'll get through as many as we can. I know there was one there around class sizes relating to the biopharmaceutical program. So I know, Colin, you typed an answer in there. But there's some other questions coming in now, so we'll get through as many as we can. Can students get an internship at NIBRT during their breaks, I suppose is one of the questions. So for maybe looking to do assistantships or internships at NIBRT. Colin, I don't know if you had any information there for that student. Colin, you're just on mute there, sorry.
Sorry, Laura. Sorry, just answer that question. So it's not a formal part of the program, but if an opportunity did arise and it aligned with the student's timetable, it would be considered. So we do have some students who do research internships, and the same could apply for NIBRT if the opportunity was there.
Brilliant. Great. Thank you. And then
Thanks.
we've got some questions that were kind of coming in through the registration. So I'll just go and have a look through some of those ones. It's relation to prepping students to the job market. So do you find within both your programs, you're developing the student skills that are directly transferable to the job market?
So I can answer that one. So yes, so our courses for the part-time and full-time are geared towards preparing students for professional careers. So both in terms of the content, we regularly review the content, and we focus on lots of different aspects of the industry to give students an appreciation, but also then to build the skills so the students can follow their interests. I said it during my presentation, but we also organize career events. So we have a number of those. We have 2 workshops, one focused on academia. So to give students a real world appreciation of what academic life is like. And then also we invite a recruitment company who specializes in biopharmaceutical manufacturing to deliver content on the course, particularly in terms of trends in open jobs, also preparing your CV, your cover letter, what's expected in different types of roles, interview skills, building your network with LinkedIn. So we really do focus on that. Like, and as we get further into the course, there's a bigger focus on that next step.
Great. I think that'll be great for people to hear. And sorry, yes, go ahead.
Yeah, just adding for the chemical engineering degree, I think because the chemical engineering sector is really diverse in terms of the employment opportunities, in terms of where people can go, there is not a single, like direction that you can go, but you can work in many, many different fields. I think one of the most important things that we provide in my program or in this chemical engineering program is critical thinking skills and general chemical engineering knowledge that makes you transferable for different industries. So I think we do, and I think we have a lot of overlap between this master's program and our undergrad program. So lots of the modules are delivered in both programs, and we do see that our graduates are very, very, very skilled to be employable. People might know that UCD graduates are one of the most employable graduates in the world. I think that is also in parts of the modules that are delivered and the skills that we give them.
Brilliant, great, thank you. My colleague Katie just posted a couple of questions that she received in the chat there. So Cassandra, I might give this one to yourself if that's okay. How do you find the workload within the master's program, maybe compared to what the workload would have been like at your undergraduate studies?
Oh, yeah. So that actually depends on the person's, where they did their undergrad, because from my point of view, where I studied my undergrad, we actually had these classes from 9 to 6. So you'll have like classes every day. You have to go on every day, and then the assignments will be there, and then the exams will be pretty, they're pretty packed up. But for me, the masters have been pretty flexible, as I've mentioned before, because we only have like 2 days or 3 days of classes, and then the assignments are, you will be given enough time to complete your assignments. So you'll have to start early, but sometimes you don't. But you'll still have to, you can still, even email your professors ahead that you wouldn't be able to meet the deadline. And if you have a plausible cause, they would actually allow it, and they will give you like an extension about that. And then for all of the projects and assignments, it's the same. And then for me, it has been pretty flexible, and the workload has come down a lot. And most of the students out there are also doing their part-time jobs. So even my friends out there, my roommates, and most of them who are doing part-time outside UCD, they could also, actually manage both of it. Sometimes it might be stressful if the part-time that you're going to, it actually depends on the part-time that we going through. So I guess it depends on the preferences. Like if you were to go through a part-time, it would differ. And if not, you are pretty much okay with the workload.
Okay, great. Thank you. And Cassandra, I'll stick with you just for the next question. It was just around someone who's maybe a little bit nervous about moving to Ireland for the first time and what supports are available for international students at UCD.
Yeah. I guess from UCD's point of view, you actually have a lot of peer mentors, and then portals that you could actually go on, and then you could just mail them. And for me personally, I didn't actually know all of that existed before. So mostly I connected with people from UCD through LinkedIn, most of the alumni over there. And if you could see someone from your place who have actually graduated from UCD, so I met so many Indian students who were already studying at UCD and who were done with the program and were working in lots of different sectors. So I could just you all of them are like building doubts. I could help you with that. So it basically depends on how you network with people. From UCD's point of view, there are so many assistance that is given. You could just type in peer mentoring on Google, and you could just see so many helps available.
Brilliant. Thank you so much, Cassandra. Colin, I might just ask you this question around the kind of maths that is covered within the biopharmaceutical program.
Probably something that I can answer best because that's the module that I'm teaching, Colin.
Great.
On first.
So I'd say it's divide and multiply, add and divide. I think subtract, sorry, that's the one I forgot. I think that's probably the extent to how far we get into maths. I would say it's probably like the maths that are taught are more. I'm joking. We also do a bit of differential equations, but it's really the maths. If one is afraid of the maths, one shouldn't be, because at the end it's kind of first year undergrad engineering maths that we're doing.
Okay, great. Hopefully that's a comfort to the person who typed that one in
Correct,
there.
Colin? Are we doing more?
Yep. Well, just to kind of add to what Georg said, the course is designed for scientists and engineers. So, I mean, if you're not comfortable with maths, you wouldn't be the first person to come onto the program. Um, and that's okay, because people have different skills. And I think if you look at the industry, like there are lots of people who have very senior roles within our industry who wouldn't be experts in maths. So we do tailor for that.
Okay, great. And then I'm not sure if you have an answer to this question. It's just
I
around
do.
biopharmaceutical. Okay, great.
Yeah, I do
So
have answers. I have answers to both of them. So
great. So yeah,
really good
just
questions, actually.
for
Really good
everyone listening
questions.
in, it's relation to is AI going to replace jobs in the pharmaceutical industry, and how will maybe the jobs be affected by the tariffs that are coming in as well?
Yeah, so I'll answer the first one. Very unlikely in the near future of our careers. So, like one thing I'd say about the industry, it's highly regulated, and because it's highly regulated, it's extremely conservative. But biopharmaceutical manufacturing is essential. It's essential from the perspective of the companies wanting to have products that work, wanting to have products that are safe. So while ChatGPT or any of the other ones might have an influence on things like social networks, it's going to be a long time before the companies become comfortable with large scale deployment of chatbots or other aspects within the industry. So AI is most likely going to be used first for things like process development, scientific data, things that are off what we call the critical path. But in terms of like large numbers of dedicated professionals being replaced by AI technology, I'd be very surprised if we see those kind of trends within the next 20 years. So really conservative. And if you make a mistake or your AI makes a mistake, it has significant impact on patients, and that will never be allowed to happen. So, but there is opportunities in AI too. So AI technology is something we cover on the course. But in terms of replacing people, I wouldn't worry about it by September 2026. Would be my opinion. The next one, the honest answer is I don't know. We all know we live in a slightly more uncertain world than we did a few weeks ago. But one thing you will learn over the course of our program is that if somebody wants to move manufacturing sites away from their current destination, it does not happen quickly. It's incredibly complex industry. It's not as simple as building a new factory somewhere else and moving everything from one over the course of a week or a month or even a year. These types of changes take as much as 8 years to come to fruition. You have to move your manufacturing process. You have to get your new manufacturing process regulated and approved in a different site. You need to have people available to be able to work in those sites. You need to have the supply chain. You need to test your process. So although certain jurisdictions would want to bring back manufacturing, it's incredibly complicated to do that. So it's a very uncertain world. There will be impacts for sure, but I don't think there's going to be any really rapid, large scale changes from Ireland as a destination or other destinations, just by virtue of the fact that it's complex. And you learn about that over the course. So you'll have a much more rounded appreciation of how the industry works. So I'll go back to the answer to the first question, which is AI. The industry is really conservative. Companies focus on product quality, on supply. So they're not going to put supply at risk. They're not going to impact the quality of their products under any circumstances. So although geopolitical things are outside of my level of understanding, what I really do understand is that it's not easy to move places. So like tariffs are tariffs. So like job opportunities is still going to be there. The one thing I can tell you for sure is that the pace at which new products are being developed is staggering. If you look at the drug discovery pipelines of companies, um, full of new exciting products that are going to make patients' lives better. But there's a real pressure on manufacturing to be able to make them, and that'll be there with tariffs or without tariffs. So the opportunities are most certainly there and are going to continue to be there. And I don't know anything about
Brilliant.
politics, and I don't even like politics.
Very, very comprehensive answer to that. So hopefully that's again a bit of comfort to the person who posted that question. So we have reached the end of our webinar today. We've kind of run out of time, and we've actually answered only the open questions are covered. So before we wrap up, just to let you know, if you do have follow-up questions after today or would like any additional resources, please don't hesitate to reach out to us. My colleague Katie and myself, we're more than happy to converse via email, and my colleague Katie will pop the email addresses for us in the chat. Thank you to everyone who joined us. We truly appreciate your time and engagement today, and I hope you found it useful, and we look forward to connecting with you in the future. And a big thank you to our speakers for your insights today. But that's it for the webinar. We hope you enjoy the rest of your day. Thank you, everyone.
Bye.
Thanks, everyone. See you later.
Bye.
Bye.
Bye.